Hi everyone, welcome back to Art of the Part. In this video, we're going to talk about the theory of insert part modeling and why it's useful for certain applications and why specifically we're going to be using it on the work holding assembly for our ye old pop topper case study. Now, whenever I talk about insert part modeling, I want you to keep in mind the terminology or the phrase parent-child references. And all parent-child references are is that we have a parent file, which is going to be your master file that has shared or common geometry that you want to link to multiple different designs, which are going to be your children. And a good way of looking at this is that your parent file is going to be a constant, and then your children or your child files are going to be the variables. And a good example would be a pulley wheel. So a pulley wheel is going to have multiple different operations. It's going to actually go through multiple different machines, and it's going to start off with a turned blank coming out of a lathe. And that turned blank might have a center bore, might have some bearing geometry, and then a specific diameter for the outer dimensions, and then probably some grooves for the belt itself. So that geometry is going to be constant throughout all the different designs of pulley wheels that we're going to make. So maybe there might be a pulley wheel with 5 pockets, maybe there's a pulley wheel with 7 pockets and 10 pockets, maybe a logo on one versus no logos on the other. And we want to keep those files separate from the parent file, but it's still linking or pulling from that geometry. But hey, maybe somewhere down the line we got an update or a revision change that the bearing or the center bore has to be updated to be either bigger or smaller. Maybe we have to add more grooves for the outer dimension for the belt. And I don't want to have to painstakingly go through and update all of my different design files to make sure that all those geometries are correct and updated, because there's a lot of chance for error going through and updating every single file one by one. I want to make all those changes on those revisions on that one master file, which is going to be our parent, and it'll apply all the way down, down through the line through all the different designs. And it's very good for mass production applications and then revision management scenarios. And another good way of looking at this is using that methodology with work holding, because I want to be using work holding in such a way that the soft jaws for specific operations that I need, I want to be pulling them off the shelf as a standardized blank. Now, I have here on the screen an assembly that might look familiar to you. This is our 5-axis vise and riser assembly. The only thing that is different is that it's holding the yield pop topper with two specifically designed soft jaws in place of where it used to be two hard jaws, which are going to be steel, ground, and very good for holding flat parts. Now, this yield pop topper here, this has a flat edge on this side, which might lend itself to our hard jaws. But on this side, there's a handful of different grooves and slots and radii that would prevent itself from being held flat in a standard hard jaw. The only two areas of flat that I have are right here and here, and those are going to be hard to reach. And you see here on the soft jaw, I actually had to make specific geometry that went up and was the negative of the profile that it could actually reach that. So think about this configuration here, which is the standard hard jaw assembly, and how difficult that would be to hold the second operation, or that all those grooves and radii of that yield pop topper. It wouldn't sit flat, and I wouldn't have a sturdy work holding assembly, which would give me a bad surface finish. It might even prone the part to release itself or fly out of the jaw, which is dangerous. So we want to make sure that we're treating this in such a way that we have optimal work holding to make a finished part. And whenever we look at these soft jaws, like I was saying, I'm pulling these blanks off the shelf. I might make 10 or 20 of these specific soft jaws, not with this geometry included, but just a blank. So that if I have another part that comes down the line, I don't have to make specific soft jaws for that. I can just pull it off the shelf and mill whatever geometry that I have in it. And I'm going to go through a couple different assemblies and part files here, but I just want to show you the process of insert part modeling. And I like to refer to it kind of like as inception, where there's like a dream within a dream within a dream. In this instance, I'm going to have a part within a part within a part. So here we are inside of the assembly file. And if I go over here to the feature tree, I have my two soft jaws, which are going to be soft jaw style A And that's just the style of the blank that I set up. These are the 10 or the 20 different blanks that I put on, or 10 or 20 quantity blanks that I put on the shelf. And I'm pulling one of them, and then I have a front and a back style that I'm going to be milling into them. So inside of these files, I'm going to right click on one of my soft draws, which is going to be the front here, and I'm going to choose open part. So I right clicked and I selected open, and that's going to open up the file here in the background. And this file here in the background, this is going to be our child. Don't get confused, this isn't our parent, but this is the child because inside here I have a specific geometry that is going to be linked to the yield pop topper. And then I have the cut that's built from it, and then a chamfer that's breaking the edge. Now, if you're thinking to yourself, hey, how do I draw this part? Because there's an extrusion here, there's an extrusion there, and then there's also a through hole on this side, or through holes on this side with counterbores. And I don't see those dimensions or those features where I can change and update them. Well, again, this is the child, and if I want to go and update the parent, where all the shared or common geometry is coming from, I have to right click on this insert part here, and I have to select edit in context, just like how I selected it inside of an assembly and I chose open the part. So I'm going to right click on the blank soft draw style A, and I'm going to edit it in context. So this file here is where all of that shared or common geometry is coming from. So I have a boss extrude that has a specific value. I have another cut extrude on the back side, which is going to be this profile here. And then I have a two corner board holes on the front side that are driving through the part as well. And this is very useful because now I can use this blank for multiple different applications, whether it be the specific geometry of a bottle opener, or maybe it might be holding round geometry because I can't hold round stock inside of a square hard draw. So this file here, this is our parent, the soft draw style A blank. And then this file here, which is our soft draw A style 1, which is the first part, F front, is going to be the child. So this is the parent and this is the child. And I have a handful of different assemblies here that are linked to this one parent file. So if I go over here to this assembly, you'll notice that I have a 3-inch round diameter that I'm holding a 3-inch round stock piece of material because I wouldn't be able to hold it in a square hard draw. And then likewise, I have a double step where I have a 4.5 and then a 2 3/4 diameter piece that is being held. And all these files, so I just showed you 3 assemblies. I have the yield pop topper, I have the 3-inch assembly, and then I have the 4.5 and 2 3/4 assembly, which is the double step. So I have 3 assemblies, and there's 2 soft draws, front and back, for each of those. So there's 6 parts in total. Now, if I had a design revision change come through and I had to actually add a chamfer edge on this, or maybe my material has to be shortened up or thinned out, I don't want to have to go through and, like I was talking about earlier, and painstakingly go one by one and update all these files and maybe make a mistake somewhere along the way. I want to actually go and just make all my changes on the master file or the parent file, and then it'll apply and trickle down through all of my different children or design components. So for instance, let's say I have to actually make this part thinner. So instead of it being about 1 inch thick, I'm going to right click on it and edit the feature. And I'm going to make this, 3/4 thick. So I actually thinned out the part. And then likewise, maybe I have to include some more clearance. For instance, I'm in a 5-axis application. The table is tilted and I needed a little bit more space on these edges here so that the spindle or that my collet does not hit the work holding itself. So I'm going to put, select the entire face there, I'm going to put a chamfer on each one of these edges. I'll make that 250. And then maybe I have to add a little bit of edge breaking on these counter bores here. So I'm going to actually go and select chamfer, and then I'll select these 2 edges, and I'll make that a little bit smaller, make that 60,000. So what I did is I took the parent file and I made the changes that I needed to make so it would update against all of my children files. So what I did is that there was a 1-inch tall face here. I made it 3/4, and then I added edge breaks to these two edges, and then I added a edge break on these two counter bores. So hopefully when I cycle and toggle through all of my different children, you'll see that those updates will apply accordingly. So I'll do it on one first, and you'll see it here. I'm gonna hold down the control key and hit the tab button. Easy way to go ahead and toggle through all of your different windows, but I'm gonna return back to my child part, which is going to be the front side of my yield pop topper assembly. And you'll notice that without actually making all these changes manually on this file, you don't see them here in the feature tree. It applied all the different features that are coming from that parent file. So it's now thinner. And then we have these two edge breaks and then these two edge breaks on the counter bores. So now I'm going to tab back over. Again, this is our parent file, the softjaw blank A. This is our child file, the softjaw A-1F. And if I toggle over here to my yield pop topper work holding assembly, you'll notice that the changes applied on this front piece because we already had it open in the background, but I have a warning here. Models contained within the assembly have changed. Would you like to rebuild the assembly now? Hit yes. And look, it actually applied the change to the back side of this work holding assembly as well as the front side. And I didn't have to go through and actually open this part. It updated it automatically. So let's see if that update will take place and change on the two diameter work holding assemblies that I had open in the background. So I'll go over here to the double step, and you'll see the same warning. Models contained with the assembly have changed. Would you like to rebuild the assembly now? If I hit yes, look at these update. A couple warnings came up, and I think that's just because the geometry is tied to the edges, but nonetheless, the updates applied. And I didn't have to actually open up these files and do anything manually. All I had to do was have the file open, and it updated accordingly. And then lastly, I'll come over here to the 3-inch diameter work holding assembly, and I'll choose yes on this update as well. And look at that. It updated no problem. Now, let's say, I updated everything and I wasn't happy with the change and I want to go back to my parent file and undo everything. So I'm going to go back to my parent file here and I said, hey, you know what? That change was bad. I don't like it anymore. So I'm going to undo that. I'm going to undo that. And I'm going to undo that. And then I'll go ahead and I'll go back into these assemblies and it says, hey, the model says updated once again. So it's pulling from the parent file. These are all my children file. Let's hit yes. And look at that, it returned back to its original shape, which was pulling from the original parent. All I did was I undid the changes that I made. Once again, I'll hit yes, updated, and then I'll go back to my yield pop topper work holding assembly, and I'll hit yes. So this is a very powerful tool as long as you set it up in the correct way. And the way that we set it up is, and I'll show you a little bit more in depth in another video, is if you do a file, new, you set up a new part, all I'm doing with this insert parent-child reference is we're going to, in the new part file, we'll go to insert, and we'll, instead of starting our geometry off, we're actually going to select part. And I'll select the blank soft jaw as long as I have it open. I can also browse for it if it's in a certain folder. But just like how I would with an assembly, I would choose to lock this to the origin. I wouldn't like randomly click out here in 3D space. So I'm just going to hit the green check mark. And then all it's saying is that the template is pulling from the drive units. We'll hit yes. And I can locate the part. That's okay. And then I'm going to go in here and I'm just going to turn off my planes. But all I did with all those different soft draws is I went in and then I just applied geometry and then I did a cut. Or sorry, that's an extrusion. I'll do an extruded cut. I'll cut that down, that distance. So that's all I was doing. All I was making was a new file and I was saving it out as my front or my back. And I was just inserting that blank soft jaw. And that's how it was updating because it was treating it as its master or its parent file. This, in essence, is my child file. So again, very good way to approach revision management, especially in mass production. And in work holding, I set up my files exactly like this so that if I have to make my change, it'll apply all the way through the line. Again, I will go through in other videos and talk about the geometry for the yield pop topper and how we're going to set that up. And I'll talk a little bit more about the systematic approach to setting up your insert part model, but this is more or less just a demonstration and talking about the theory and how easy it is to update your files accordingly. So I'll catch you in the next video.